Oh, hello. Prepare to learn with Teacher Jen on the topic solving linear equations in one variable. Let's have a look at the lesson overview. This is actually a lesson for grade 7 learners. However, this is also a review lesson for other grade levels, specifically for linear equations in two variables in grade 8, before students deal with quadratic equations in grade 9 and polynomial equations in grade 10. So it's a lesson for grade 7, but it's also a review for other grade levels. What are the competencies or what is the competency addressed? We have for grade 7, finding the solution of linear equation in one variable. Using the prerequisite concept, what should we know? We should know how to simplify algebraic expressions. Also, in this video, we will take a look at the difference between the expression versus equation, solving an equation using addition or subtraction, solving an equation using multiplication or division, and solving an equation using both the multiplication and addition. So what's the basic difference between expression versus an equation? For an expression, this consists of variables, numbers, and functions or operations while missing the equality symbol or the equal sign. Say, for example, 8x minus 3x plus 2 minus 8. No equality symbol. For an equation, it contains numbers, variables, functions or operations, and the equality symbol or the equal sign. Say, for example, 8x is equal to 3x plus 2, the presence of the equal sign. What do we do in an expression? We simplify an expression. Equation, we solve an equation. What do we mean when we say we simplify? Simplify means we perform the operations applying the PEMDAS rule, meaning to say parentheses. We deal with the exponents first before we multiply or divide, then others subtract from left to right. In the original given expression, 8x minus 3x plus 2 minus 8, we combine similar terms. That is simplifying algebraic expressions. We only can combine terms which are similar. Similar meaning to say we have the same variable with the same exponent. 8x minus 3x can be combined. That's color-coded for us to easily see. 2 minus 8 also is combined. So 8x minus 3x is 5x, and 2 minus 8 is equal to negative 6. Thus, the expression 8x minus 3x plus 2 minus 8 was simplified into 5x minus 6. To solve an equation means we find the value of the variable that makes the equation true. How? We apply simplification still and the different properties of equality, whichever is applicable on the given situation. So let's do that. We solve for x in x minus 22 is equal to 54. We write first the original equation, not right? And then remember, we have to isolate the variables or the terms with the variables on one side and the terms without the variables on the other side. And on the left side, we have x minus 22. So how do we do the segregation? We add 22 to both sides of the equation. We have x minus 22 plus 22 is equal to 54 plus 22. Why can we do that? We are applying the key concept. If an equation is true and the same number is added to each side of the equation, the resulting equivalent equation is also true. In symbols, this is actually the addition property of equality or the APE for any real numbers A, B, and C. If A is equal to B, then adding c to both sides does not change the equality. We have a plus c is still equal to b plus c. So continuing, we simplify. We know that we can add negative 22 plus 22. That would give us 0, leaving our left side to contain only the x. And on the right side, 54 plus 22 is equal to 76. Let's check for the truth. So checking, we have x is 72. So instead of writing x, we write 76 rather, minus 22. And would that be equal to the right side, which is 54? So 76 minus 22 is actually 54 on the left side, and that is equal to the 54 on the right side. We have a true equation. Second example, 32 plus m is equal to 70. We again write the original equation. And then remember, we isolate the terms with the variable on the left side and the terms without the variable on the right side. So what do? We apply the addition property of equality. What is that number that we are going to add to both sides of the equation? It's negative 32. How did we get negative 32? It's the additive inverse of 32. So we do that. We say 32 plus negative 32. All right. I forgot to write there the m. So plus m is equal to 70 plus negative 32. Then we simplify by performing the operation. So negative 32 plus negative 32 is again 0, leaving us with m simply on the left side. And on the right side, 70 plus negative 32 is 38. So again, if we're going to check, we have 32 plus 38. Would that be equal to 70 on the right side of the equation? And 32 plus 38 is really 70. 70 on the left side is equal to 70 at the right side. What about if we have solving for y in 2 times y is equal to 6? I repeat, 2 times y is equal to 6. Again, we write the original equation. Then we think, oh, that is 2 times y. So how do we undo 2 times y? We multiply both sides of the equation by 1/2. Or actually, we're applying multiplication property of equality. There. 1/2 is multiplied to both sides of the equation. Where did we get that 1/2? It is the multiplicative inverse of 2, or that is the reciprocal of 2. Again, why are we allowed to multiply both sides of the equation with the same number? We have here, if an equation is true and each side is multiplied by the same non-zero number, the resulting equation is equivalent. In symbols, for any real numbers, a, b, and c, if a is equal to b, then ac is equal to bc. So, simplifying that, 1/2 times 2 is 1, so that we are left with the numerical coefficient of y to be 1. So, 1y. And then on the right side, what is 1/2 of 6? Or 6 times 1/2? That is 3. So, the value for y is 3, and it's easily checked. For checking, we say 2 times the value of y, which is 3. Would that be equal to 6 on the right side? 2 times 3 is 6, which is equal to 6 on the right side. So good. Another example. Solve for y in 4/3 times y is equal to 12. Again, the original equation, 4/3 y is equal to 12. Then, we multiply both sides of the equation by the same number, or we apply the multiplication property of equality. Why is it that we are multiplying both sides by 3/4? Remember that the coefficient of y is 4/3. So we get the multiplicative inverse or the reciprocal, and that is 3/4. So 3 fourths times 4 thirds y is equal to 12 times 3 fourths. And we can see here that 3 divided by 3 is 1. 4 divided by 4 is also 1. And we are left on the left side with 1 times y, or y. And on the right side, we also simplify. What is this? 12 divided by 4. We can actually divide 12 by 4. That is 3. So 3 times 3, we are left with 9. So the value for y in 4 thirds y is equal to 12 is 9. Now, we have this equation. 4 times y minus 3 is equal to 5. So on one side of the equation, multiplication is involved as well as subtraction. Again, we write the original equation. 4y minus 3 is equal to 5. Then what are we going to do? We apply first the addition property of equality, segregating or separating on sides of the equation the terms with the variable and the terms without the variable. So that, what do we add to both sides of the equation in order that the term with the variable will be left? It's the additive inverse of negative 3. That would be 4 times y minus 3 plus 3 is equal to 5 plus 3. Same number is added to both sides. And simplifying by addition, negative 3 plus 3 is 0. So we are left with 4y on the right side, and 5 times 3 on the right side is 8. Then, we have to apply the multiplication property of equality so that we are left with the coefficient of y to be 1. 4 times y, the coefficient of y is 4. So we get the reciprocal of 4, and that is what we use to multiply both sides of the equation. So 1/4 times 4y is equal to 8 times 1/4. And on the left side, what is 1/4 times 4? You have actually 4 divided by 4 is 1. So we are left with the coefficient of y to be 1. And on the right side, what is 1/4 of 8? You have 2. So the value of y is 2. We check, substituting y with the value which is 2. 4 times 2 minus 3, is that really equal to 5? So 4 times 2 is 8, minus 3 is equal to 5. And 8 minus 3 is actually 5, and the right side is 5. The equality symbol is preserved. Thus, we have solved for the correct value of y, which is 2. Another example, we have 11 minus 2x is equal to negative 5. So what are we going to do again? The original equation we write 11 minus 2 times x is equal to negative 5. Then we have to apply addition property of equality. So we have 11 plus a negative 11 minus 2x is equal to negative 5 plus a negative 11. So that when we are going to simplify, you have negative 11, or 11 plus a negative 11 is actually 0. So that you are left on the left side with negative 2x, and on the right side, negative 5 plus a negative 11. Remember, adding like signs, you simply add 5 and 11 and affix the negative sign. So that we now have negative 2x is equal to negative 16. We're not yet done because the coefficient of x is not positive 1. So what do? We apply the multiplication property of equality. What do we multiply to both sides of the equation so that the coefficient of x will become 1? Take a look at numerical coefficient. It's currently negative 2. So what is the multiplicative inverse of negative 2? It's negative 1/2. So Multiplying both sides of the equation by negative 1/2, we then arrive at simplifying by multiplication. We have negative times negative is positive. 2 divided by 2 is 1. So we are left with 1x. And on the right side, negative times negative is positive. There's no need to write that. And what is 1/2 of 16? 8. Or 16 divided by 2 is 8. That is now the value of x. In the equation, 11 minus 2 times x is equal to negative 5. So, with those examples, I hope that we should remember the following. So, what should I remember? Number one, whatever I do on the left side of the equation, I must do on the right side. Next, for any real numbers a, b, and c, if a is equal to b, then a plus c is equal to b plus c. That's the addition property of equality. And for any real numbers a, b, and c, if a is equal to b, then a times c is equal to bc, or b times c. That's the multiplication property of equality. So these were what we have applied in solving the equations. So again, don't forget this as you solve linear equations in one variable. Thank you again for being with me. Thank you for watching. Thank you for listening. And I hope that you have learned something in this review. Thank you, everyone. Have a good day.